Here is another useful limit, special limit. Limit x approaching a of x to the n is a to the n, where n is a positive integer. Okay, guys, this is nothing very deep. Likewise, by the way, x approaching a of nth root of x is nth root of a, where n is a positive integer. So we are looking at positive roots. Okay, we don't want any denominators. So secondly, we are looking at integral roots. We don't want any strange situation like rational roots and so on and so forth. Okay, these are simple examples. If you like, you can look at the graphs. Let's see the graph of y equals x. Notice how it has no breaks. So given any number a, say a is 7, at 7, right hand branch and left hand branch, they all meet. So there is no break, you see. So you're never going to have a separation of the two branches. So the limit always exists. Same thing. Let's look at higher powers. X to the power 2. Well, you know parabola. X to the power 3. This is cube. There are no two branches. There is no breakage anywhere, right? So x to the power 4, right? Looks very much like the parabola, but it isn't, okay? X to the power 5 looks like x cube, but that's the point of all odd powers, right? Now suppose you want to look for roots, okay? So what is a root? Say I will say square root, but I will use this option. So I need to use the shift button. So that gives me. So cube root of x. Look at that. It's well connected. Say I go to fourth root of x. It is well connected. Say I go to fifth root of x. It is well connected. Sixth root of x. It's well connected, and so on and so forth. All right. So there are no breaks in your branches. Therefore, the limit will always exist and will agree to the actual value. Okay. No breaks, no removable discontinuity, nothing. So with this particular information, you can talk about limit of a root of a function, not just x, function inside. Well, limit of nth root of a function is nth root of the limit. That's what is happening. Okay, so we are looking at positive integer roots. N's have to be positive. If n is even, we assume that this limit is greater than 0. Why? Because if you are looking at an even root, right, square root, fourth root, the object inside should be positive, or you become a complex number. So as to avoid complex numbers, you are requiring this. All right. Direct substitution property. If you have a polynomial or a rational function and a is in the domain of f, then limit x approaching a f x is f of a. So this is direct substitution. To find the limit of a function, all you do is plug it in. When do you plug it in? If f is a polynomial or a rational function. Rational function means polynomial over polynomial, and a is in the domain. Okay, we will see examples. If fx is equals gx for all x not a, then the limit also has to be equal as long as limits exist. This is an important rule. Okay. Here is an important theorem. Limit x approaching a fx is L if and only if left hand limit is L and right hand limit is also L. Okay, this is what we have been seeing all this while. As long as left hand limit and right hand limit agree to a certain number, that number is your limit. Okay. If you have two functions f and g such that one is always less equals g, okay, whenever we are near a number a, okay, near, except possibly at a who cares, as long as near a, fx is less than or equal to gx and the two limits exist, then limit x approaching a of fx is less equals limit x approaching a of gx. Which brings us to what is called the squeeze theorem. Squeeze theorem is also called the sandwich theorem. If you have three functions, fx less equals gx less equals hx, okay? So gx is sandwiched between these two. Now, if the end functions approach the same number, L, then the middle function has to approach the same number, L. So there is an then, okay? So, important point, G is sandwiched between F and H. Both F and H approach the same number, then the middle guy has to approach the same number, okay? There is a very nice picturization of this. Here we go. F is here below, H is here above, and G is sandwiched between the two. Notice G could go far away, right? But near A, G is stuck between these two. So much so that H is approaching a certain number L, F is also approaching the same number L, then G gets squeezed between the two. Therefore, G will also have the same limit. Okay? Squeeze theorem is also called sandwich theorem or the pinching theorem. Alright? So, this completes the lecture slides for section 1.6. Next videos will cover problems from the web work on section 1.6. Alright? Until then, bye.